Hello and welcome to Equation of a Circle. This is the last topic of the year. Here we go. It's been a minute. Find the distance from the point 1, 2 to the point 4, 6. And typically you would use the distance formula. And we basically just plug in to that formula right there. So plug in your x and your x, 1 and 4. Plug in your y minus y, 2 and 6, and work out the equation. Start inside your parentheses, so this would be -3, this would be -4. Work that out, that's 9, that's 16, square root of 25, which is 5. So this point is 5 units away from that point. What does this have to do with the circle? Well, let's say you have, we're going to use this equation. Let the point HK be the center of any arbitrary circle. So let's put it right there. Let's call this the point HK. Oh, right there in my graph. There we go. Let the radius be the distance from the point HK to an arbitrary point XY. So let's say I put XY over here, like that. So what I just did was I made a length, and I'm going to find the distance from here to here. I'm going to use the distance formula, which we have right here. So distance formula is x1 minus x2 squared plus y1 minus y2 squared. And what I'm going to do is I'm going to plug in this part as my x1. So distance is equal to, we're going to use xy as my x1, y1. So like that, I'm going to do x and y. And then I'm going to plug in HK for my x2, y2, like that. Okay, so there's my distance formula. We have 2 random points just plugged in to that. And then watch what I can do. If I can square both sides of this equation, and that gets rid of the square root. So what we have here is d squared is equal to x minus h squared plus y minus k squared. And this is looking a lot like the Pythagorean theorem. A squared plus b squared equals c squared. Yes, it's d, but Pythagorean theorem, we have blah squared plus blah squared equals blah squared. That's Pythagorean theorem right there. The distance formula is just a disguise of the Pythagorean theorem. And now if I go out the same distance, I don't know, it'd be like right around there. I go out the same distance right around there, and I go out the same distance right around there. What ends up happening is I end up developing a circle. It's a very bad circle, but it ends up working out where the distance that I just found is equal to the radius of the circle. So instead of putting d squared, I can put r squared. It's the same thing. And this is the equation of a circle. I can graph it. I can go to a grapher and graph it, and that'll give me any circle. Any circle such that HK is my center and R is my radius. So there you have it. This is the equation of a circle. You can now graph a circle in a coordinate plane. If you want it restated, here we go. Standard equation of a circle in the coordinate plane with standard equation of the circle is x minus h squared plus y minus k squared equals r squared, such that HK is the center and the radius is r. So how can we use this? We can do the following. Write an equation of a circle that has a radius of 4 and a center at the origin. Now origin means 0, 0. Okay, so here's my equation of my circle. Okay, And it says it has a center at the origin. That's our HK. It says HK, so we're going to start plugging in. H would be 0, and that would be 0. So there's my H and my K plugged in. Notice I used a minus sign. And then it says an equation of a circle, so we just got to do x, y. So I just start any x, y point would do. This is like an equation. And then let's see what it says. It has to have a radius of 4. So like there it is. There's an equation of a circle. It'd be 4 squared equals x squared minus y squared. That is technically a circle with center at 0 with a radius of 4. And you could also write this like this. That would also be the same equation, just moved it over and I squared it. So there it is. That's an equation of a circle. Example 2. Write an equation of the circles shown below in the diagrams. So this one has center 0, 0. And this one also has center 0, 0. This one has a radius of 2. This one has a radius of 3. So here's how we would write that. We would start out with 2 squared. And then we have to do x minus h, y minus k squared. So it would be, why did I do a square root? I'm used to doing this distance. 2 squared equals x minus 0 squared plus y minus 0 squared. 0, 0 because it's at 0, 0. And we could rewrite this, we could call it x squared plus y squared equals 4. It would be the same thing as 2 squared, and it's just getting rid of the zeros. We don't have to write the zeros in there. So that's that one. So what could we do for this one? Could we go a little quicker? Yes. X squared plus y squared equals r squared. R squared in this case is 3, so r squared would be 9. That would be this is the equation of this circle. If I put this in my calculator and graphed it, the calculator would spit out this circle right here. All right, so here's one that's offset. This one, the center is not at 0, 0. So the equation goes like this: x minus h squared plus y minus k squared equals r squared. That's the circle. I have to plug into that. We can see that we'll do x minus, what is this point? This point is the point 2, negative 1. So this is our h and our k, hk. So we'll plug in for h, we'll plug in 2. And then y minus, what is our k? Our k is negative 1. That's the point 2, negative 1. So you'd have to plug in a negative 1 for that. That's going to be a negative negative. We'll take care of that in the next step. And then the radius, you can count, would be 3. 1, 2, 3. So there it is. I just plugged into the equation of the circle. You're literally just plugging in the center, you plug in the radius, you're good to go. Now let's clean it up a little bit. We would call this x minus 2 squared plus y plus 1 squared equals 9, more than likely, is how you're going to see that. All right, so if I'm given this, I can tell from this, the center of this circle is at 2, negative 1, because it's minus h and it's minus k. So h is 2, k has to be negative 1, and the radius has to be 3. All right, next one. Next question. Write the standard equation of the circle with center here and radius here. So again, you can start by, I always write the equation out, but perhaps you can skip this step right there. Center, this is your h and this is your k. So we'll do x minus negative 4 squared. Notice I'm using minus negative because h is negative 4, so I have to plug in negative 4. And then I do plus y minus negative 6, and then 5 squared. So to clean this up, we could call this x plus 4 squared plus y plus 6 squared equals 25. That is the equation of the circle. And you can tell from this that the center is negative 4, 6, and the radius is 5. Next page. Let's graph a circle. So we're kind of going backwards. This time I can tell that my center, this is H and K. So HK is the point 1, 2. Not -1, not -2, but just 1, 2. And the radius is 2. This is r squared. So the radius must be 2. So if I'm graphing this, I can just make myself a graph on here. I can go to 1, 2 on the graph. We should label our graphs X and Y. And I guess it's kind of assumed that these are just units of 1. So we're going to go to 1, 2, which would be right there. There's the point 1, 2. That's our center. And then we're going to go out with a radius of 2. So go out with a radius of 2. There's a radius of 2, up 2, over 2, down 2, and kind of make my circle from there. There it is. There's the circle. This is the information given to us. We're able to take the equation and turn it into a circle. It's pretty cool. All right, next one. This one can be rewritten as x plus 2 squared plus y minus 0 squared equals, I guess we can call it, let's just call it 2 squared. So this one, what's the center of this one? This one's H and K. This one has a center of -2, 0. -2, 0. Why is it negative? Because this has to be x minus h. So it's got to be minus -2 to make this a positive here. All right, so let's go ahead and graph it. We're going to, oh yeah, and then r equals 2. You can see that right there. So let's make ourselves a graph. X and y. And we'll go to the point -2, 0. There's my center, has a radius of 2. So go over 2, up 2, over 2, down 2. And there's my circle right there. There it is. It's like magic. We can turn an equation into a drawing. Okay, next. Here's some more examples of some questions you could see. These are SAT practice questions. The XY plane, a circle with a radius of 5. So that means r squared equals 25. So we don't want this or this. We want r squared. R squared is 25. So we're going to see it's one of these. Has a center of -8, 6. So that would be this one and this one. Remember, your equation is x minus h and y minus k. That's what we're looking for. So that would be B. And a lot of people put A here because -8, -8, 6, 6, but it's minus h. So it's minus negative and minus 6. So this is minus positive 6. B is the correct answer for that one. Number 2, the equation defines a circle in the xy plane. What is the radius of the circle? The radius is r squared. R squared equals 121. So r is the square root of 121. R is 11. I guess that's not a multiple choice, but it works. It's all about this right here. X minus h, y minus k. And the center, follow-up question, the center of this circle would be -6, -3. Again, watch out for those positives there. It's minus, minus. And 3. All right, defines a circle in the xy plane. What are the coordinates of the center of the circle? I need my h and my k. This is not nicely written like this. This is different than what we've seen. So So what we have to do is we have to do some factoring. So we can take this and call this x plus 20 times x. So what I did was I took an x out of here and I took an x out of here. And then we can do this. Like that. Equals negative 20. Huh. I went cross-eyed. I'm not sure that's the way you're supposed to do this question. What am I missing? We'll come back to that one. I gotta think about that one. I am sorry. Guess what? This happens. It's been a long time since I've taught this. Let's go to the next one. This one won't be a problem. Number 4, classic circle. R is 4, because 16 is 4 squared. Point P is on the circle and has the coordinates blah. If PQ is a diameter of the circle, what are the coordinates of Q? Really should have worked this out before I did this video. Let's go on to the next question. A circle in the xy plane has an equation of the following. Which of the following points does not lie in the interior of the circle? Well, it's got a radius of 5. You know what? Tune into the next video. Be right back.